Good evening, everyone. Welcome back to White Fortress Cybersecurity. And we started networking fundamentals. And today we will be covering OSI model. And in the last video lecture, I wasn't able to complete it due to because I had a visitor. But today we will be covering all of it. So let's start. So in the last videos, we covered all these topics: type of IP, versions of IP, classes of IP, ports, MAC address, and your types of computer networks, how they are divided based on certain conditions like ownership, service and control, geographical area, peer to peer model, client server model. We have completed all of this: PAN, LAN, MAN, WAN, packets. Okay, so now let's do this ping thing. There is a command ping, and it uses a protocol, that is your ICMP protocol, Internet Control Message Protocol. So basically, this protocol is used to check the performance of a connection between two or more devices. If the connection exists or is reliable or not, if the host is reachable or not. How? So simply, I'm going to open command prompt, and here I'm going to simply type the command ping and then whosoever I want to ping. Hello, Shubham Yadav. Welcome back to the channel. Welcome back to the channel, everyone. Now we have got ping, and here I will simply type a domain name or an IP address. So, for example, there is this website www.whitefortress.in or google.com or indeed.in, any website. Okay, so this is a particular website, and I can either simply write the domain name. I can simply ping this domain. This is domain. White Fortress is your domain, and I can simply directly ping it, or I can also ping the IP address. Where is the IP address? So I told you about this tool Shodan in the previous classes. Here is this extension Shodan, and here I can just simply pick this IP address, or I can just ping this over here. Okay, just a second. Let's copy it again. Okay, so here I'm getting the reply from this specific IP address. Also, I can write the domain name like ping, then whitefortress.in. I can either write the command or I can write your IP address or domain name, anything. Hello, Krishna. Welcome back to channel. I am good, Shubham Yadav. How about you? Good evening, everyone. And now what we have to, here you can see by default there are four packets, right? Sent 4, received 4, 0% packet loss. That means that the connection is very reliable. If there is packet loss, that means the connection is unreliable. And here we are gonna we can also change the number of packets that we want to send. So let's write the command ping slash forward slash question mark. So here you can see the help menu of this. So here we have n hyphen n is for your count, or you have got this hyphen 4 hyphen 6. Hyphen 4 is your for IPv4 for pinging a specific domain on IPv4 address, and hyphen 6 is for your IPv6 address. Now, I'm going to simply type again ping, then whitefortress.in, and here I'm going to put hyphen n, that is for your count, number of packets you want to send. So, for example, I want to send 6 now. So, here you can see 1, 2, 3, 4. Previously, by default, it was 4 packets. Now, this time, send 6, receive 6, and 0% packet loss. So, this is how we can even modify the packet numbers, ping packets that we want to send. So here you can see this is how. Also, we by using this we can also get the IP address of a specific domain. Okay, here you can see if I put www.whitefortress.in, this is the IP address 142.251.223 and 147. Okay, here also using the Sudan, we have got the similar IP. It's probably because of the different IPs because of your where it is hosted, right? VPN might be there, and okay. So what basically happened with the protocol that was being used in pinging a specific system? Like for example, I tell you that whenever you get a doubt, you can just ping me on the number given in the description below. What does it mean? You can say you can check if I'm available or not. You can send me a message and I'll reply back to you as soon as I am available. Okay, so ping also checks the reachability, the performance of a connection. If there is a packet loss, that means the connection is not reliable. If there is no packet loss, means connection is reliable. So this is a simple activity for you to do. Ping google.com. I hope guys you know this command, what command you should use. So it's the ping command only. Now let's talk about some important protocols. These are two transport protocols. Okay, why they are called transport protocols? Because it works on transport layer of OSI model. So we will see that today as well. And guys, if you get any doubts, any questions, you can let me know in the chat, or after the class, you can let me know in the comments below. हाँ. Okay. So TCP and UDP protocols are known as transport protocols. क्या हुआ? सही है कोई नहीं अभी रहने दो. कोई नहीं. Okay. So TCP and UDP protocols are known as transport protocols. Here you can see uh, that whenever client, who is your client? Client is basically your browser, sends a request from the server. It is asking for example, I typed here in my browser anything like google.com or anything like that. So what will happen? A request from my system will leave to the server. It will reach google.com server. Or if I type whitefortress.in, it will reach the server where whitefortress.in is hosted. And it will respond me back with the web page, right? So what happens first of all? First of all, these kind of protocols are used that client will request the data, synchronization packet will go, that it will ask the server, are you available? Then the server will acknowledge it that yes, I am available and synchronize that are you available. Then the client acknowledges it too that yes, I am also available. Now let's start the conversation. Now, other protocols like HTTP for bringing the site or FTP for the file transfer will begin. So here is another example. For example, this is Alice, this is Bob, and Alice wants to talk with Bob and wants to send some file, wants to share some secrets or anything like that. So it simply texts Bob, hi Bob, can you hear me? Or calls Bob or something like that. So it synchronizes that, am I audible to you? Can you hear me? Then the Bob says like, hey Alice, I can hear you. It acknowledges that yes, I can hear you. Can you hear me too? And it also tries to synchronize. Then the Alice also acknowledges, yes, you are also audible, and now let's talk. Let's talk means now it will use, the client and server will use other protocols like HTTP, FTP, etc. Okay, so this is your TCP. TCP's full form is Transmission Control Protocol. But what happens when UDP, User Datagram Protocol, is used? So, for example, client asks for some kind of data. And guys, please do not forget to like the video. Good evening, Louise. I wasn't getting your messages. Now I'm getting them. And ma'am, today Adarsh has gone earlier. Ma'am, I'm alone. Do you guys stay together or what? I don't get it. Adarsh is gone and I am alone. That's. Are you guys roommate or something? Very good evening, everyone. Very good evening, Louise. And what happens when the client requests some data? Okay, just ignore the arrows for now. Client will definitely ask for the data. ठीक है, योगी. So what will happen? The server will start responding with the data. It will not make sure if all the packets are being sent completely or not, or stuff like that. Okay, so it will just simply request the data, and the server will start responding with the data without making sure if there is a packet loss or not. So TCP keeps track of lost packets and makes sure that lost packets are resent. Okay. So your TCP also makes sure that, like for example, I'm sending a file to you. There will be lots of packets. The file will be divided into multiple packets. So one by one from my system, the packet will go to your system. So it will make sure that all the packets are sent, even if a single packet is not, it doesn't reach the system. Okay, what will happen? The file will get corrupted. So it has to keep track of lost packets, and also it adds the sequence number so that all the packets arrive in the correct order. Like first of all, there is the first packet should reach the another system, then second packet should reach, then third packet should reach. So it adds the sequence number into the packet. So the receiving system knows that which packet it has to receive first. It will wait for the first packet, then second packet, then third packet. And if another packet reaches quickly, like fourth packet reached, but third packet hasn't reached yet, so it will wait. And your TCP is slower because of all these added functionalities as well. And TCP requires more computer resources because the operating system needs to keep track of the ongoing communication. And just like I told you, it has to resend the lost packet. It has to keep track if the packets are going in the correct order or not. So it also takes more computational power rather than the UDP. And it manages sessions on a much deeper level. So this was your transmission control protocol. Now, UDP, User Datagram Protocol, it does not keep track of lost packet and does not care about the packet arrival either. So, your TCP after this TCP handshake thing, what happens? Your HTTPS, FTP like protocols are used. But what happens in this UDP protocol? Uh, like for example, I'm calling or anything like that. So in calling or in video calling, you can see there is some, like there can be voice break, or there can be, video break or something like that. Blurry video. That is all because of the packet lost. Because in video calling or phone calling, UDP is used. So UDP doesn't keep track of lost packets, and it does not care about packet arrival order either. It doesn't care that if the packets are arriving in this correct order or not. That is why it is more faster, because it lacks any extra features and requires less computer resources as well. So, examples: DNS, IP telephony, DHCP, and many computer games uses UDP. So, both TCP and UDP protocols are equally important. Why? Because TCP is used for sending more important data like your files, folders, or anything like opening a website, or sending a file, anything like that. So it makes sure that all the packets arrive in the correct order. But UDP does not need that, but it is also very important for the calling, for the video calling. The packet should reach from one system to another system in a very fast manner for the calling and for the video calling stuff. Okay, next is your components of network. So in components of network, we have got end devices, intermediate devices, network media, and here we go with the end devices. We have got the devices like your PCs, your laptops, mobile phones. These are all end devices. End devices are those devices which either show some output and where input, like it receives input and shows some output. Like for example, I'm here typing google.com or something like that. So it is taking the input, and when I type this google.com or whitefortress.in, then it is also showing the output here only, right? So end devices are those devices, are client devices which are used to take input and show output. So, next is your intermediate devices. Intermediate devices have just one main purpose. What's that one main functionality of your intermediate devices? Whenever they receive a packet, they takes the packet and they forwards the packet. Okay, so what they do? They receive the packet and they forward the packet onto the correct path, onto the correct destination. So, intermediate devices simply works as the intermediary between the source and the destination devices. Next is your network media. We all know what is network media. It's cables or your wireless uh, or light beams or something like that. Okay, infrared light beams and satellites also use also use your wireless media, and other network medias are cables. So no need to go very deep into this for understanding the OSI model. This much is enough. So end devices, example, desktop computer, laptop, printer, IP phone, wireless tablet, and even your TVs these days, telepresence endpoint. Here you can see. So these are all end devices because they either receive the input and give out some output. What are your intermediary devices? Routers, switches, LANs, and a wireless router, multi-layer switch, firewalls. These are all your intermediary devices. Network media, wireless media, LAN media, WAN media. This is all your media. Then we have got OSI model over here. So guys, if you have any questions, you have any doubts, you can let me know in the chat, and do not forget to like the video and subscribe to the channel and stay connected with us. Also, if you need mentorship in any course like ethical hacking, cybersecurity, any cybersecurity course, we are here to help you with. And we also provide certifications, globally verified certifications. You can let us know, and the number is in the description below. You can register over there. Now, OSI model, Open System Interconnection Model. This is the full form of your OSI model. This is a very important model which explains that how from one system to another system, how data is transferred. Okay, so this is a very important model. Even in the interviews, this is a very important question, even for the interviews. This topic just comes most of the times. So OSI, Open System Interconnection Model, was developed by International Organization for Standards ISO, and it describes the flow of information from one computer to another. It is a logical model, not a physical one. So what does it describe? The flow of information from one computer to another model, another computer. So it is not, it is a logical model, not a physical model. What does that mean? Means it is not physically implemented. It is not implemented in real life. What is implemented in real life then? That is your TCP IP model. We will learn about that just right after the OSI model. For learning that, OSI model is the key. Okay, it is a very short topic, TCP IP. If you know the OSI model, TCP IP model is nothing for you. And this OSI model is a logical model. It is a more detailed model, and every layer, it has got Seven layers. Here you can see this is the OSI model. It has got seven layers. One, two, three, four, five, six, seven. Okay. So every layer is a set of protocols that developers can use to create and implement applications to run on a network. So what is this is the use for creating and implementing applications to run on a network. Therefore, it explains how devices communicate on a network. It explains how devices exchange data with each other. So, this is your seventh layer, application layer. Then presentation, session, transport layer, network layer, data link layer, physical layer. Physical layer is your first layer. So, whenever someone asks you what is your second layer, something like that. So you will say data link layer. You will not say presentation layer. Okay, presentation layer is the sixth layer. So client to server side, or the sender to receiver side, from seventh to one layer, and at the receiver side, first layer to seventh layer. Okay, we'll see that how that works. Just a second. Okay, let's start this. Guys, if you get any question in this topic, this is a very important topic. So just let me know right in the chat. Okay, let's start this OSI model now. OSI model. So seventh layer is your application layer. How do you remember these? For for people who understand Hindi, for them write this mnemonic. आज फिर से टेस्ट नहीं देना पड़ेगा. Okay, and for the people who do not understand Hindi but they do understand English, please do not, uh, please do not, just a second. Mnemonic, what happened? Spinach on my pizza. It was something like that. Pineapple. Mm, English mnemonic for OSI model. Mnemonic. All people seem to need data processing. All people seem to need a penguin. Okay, there are so many. There was a very easy one. Okay, a penguin said that nobody drinks Pepsi. That is a very funny one. A penguin said that nobody drinks Pepsi. A penguin said that nobody drinks Pepsi. Okay, so this is how you can remember this. So in the OSI model, application layer is the seventh layer. Application layer, then your presentation layer, session layer, transport layer, network layer, data link layer, and your physical layer. Okay, so what is your application layer? Application layer has the user interface. For example, it is because For example, something- for example, I want to send you guys a file. Okay. And I have to go to my user interface and I will upload the file. Okay, like for example, I want wait, is my voice cracking? Is my voice cracking? Is it still? Is it still? Is it still? Lizzie, can you please confirm if my voice is still cracking or not? Hello. Okay, so for example, I want to send you guys a simple file. So I simply uploaded it onto my Google Drive or something like that. Okay, so what is this? I'm uploading it here. I am using my user interface. So here we go. Why is it not working? Okay, interaction between the user and the application takes place at your application layer. Okay, that's great. Now it's fine. Thank you for confirming, Louise. Next is your presentation layer. So now when I just uploaded it or I just simply sent you, okay, I simply sent you on WhatsApp. I sent you a document or some notes on your WhatsApp. So what happens? I simply, first of all, using the WhatsApp application, I'm interacting with the user interface and sending you that specific file. So here, protocols like HTTPS, HTTP, FTP for file transferring are used. So these are the protocols. And I told you all these layers are nothing but some set of protocols only. Next is your presentation layer. Now, whatever the file I sent you using that FTP protocol, what will happen? The file will translate, encrypt, and compress. Okay. So I am saying it will be compressed. What does that compressed mean? Means, for example, that was a 5 GB file. For example, it was a 5 GB file. Now, it gets compressed over the network into something like 2 GB or something like it will just get compressed. Okay. For now, if it will get compressed, how will it help? If it was 5 GB, now it's 2 GB, means lesser packets, means more, much faster transfer of data from my end to your system. Now, next is your encrypt. Encryption means encryption. So, what does encryption means? Like, for example, my file was had some crucial data, okay, and it was converted into some gibberish like this, which is not understandable. So, this is your encryption, converting plain text into ciphertext. Converting plain text into some unreadable or ciphertext. Okay, it gets encrypted and translated. Translated into what? It gets translated from sender format to receiver format. Okay, this is how it works on the presentation layer. What happens? Compression, encryption, and translation of data occurs. Guys, if you get any doubt in this topic, just let me know. It is a very, very important topic. Okay. Next is your session layer. What will happen? The session will establish session establish between the sender and user and is also maintained. And later words, it's also terminated. So session is established, maintained, and terminated on this session layer. When all the data is sent, when data is started to send, the connection will establish. till the data is being sent from my system to your system, it is being maintained. The session is being maintained. And when all the data is gone from my system to your system, the session will terminate. So that is your session layer's job. Next, it is your transport layer. So transport layer got these protocols, UDP and TCP protocols. I told you that these TCP and UDP protocols are your transport layer protocols. Why? Because here the packets. Okay, this was all data. Okay, on application layer it was data. Okay, I hope uh, decreasing this size won't affect you guys. Okay, it was data over here. Here also on the presentation layer also it was data only. The data remained data. But here it was just the data was compressed, encrypted, and translated. Here at the session layer also, the data remained data only. But on the transport layer, the data divides into segments, into small, small segments. And with the segment, here you can see TCP and UDP like protocols. With the segment TCP, UDP, TCP or UDP. This is your segment header. This is called your segment header, and here the data is converted into small, small segments. Now, next is your network. In on the network layer, your IP address of source and destination system plus your segments. Okay, segments. So IP address, what will this IP address do? Routing occurs here. What is routing? Can anyone tell me? Routing. What is your routing? And here you have got IP address of source and destination and the segments. This is your header, and IP address plus segment on the network layer, this data becomes packet. On these three layer, application, session, transport layer, it was data, and on the network layer, it will become packet. Can anyone tell me? And guys, please do not forget to like the video and subscribe to the channel. There are very few likes, only 4 likes today, even when we are learning a very important topic. Guys, please do like the video. And can anyone tell me? Network layer ensure the transmission of data from host present at a different network. Yes, exactly. It do. These all the layers ensure the transmission of data, but this has got okay, let me tell you what exactly routing is. Routing means routing the packet. Okay, routing means routing the packet means it uh, tells the packet which path you should take. Routing is which path each packet. There will be a specific path for the each packet, the best path for the each packet. Devices like router decides the best path for each data packet. And here IP address is added to the segment. It became segment at the transport layer, and here at the network layer the data becomes the packet. Ma'am, show us about DDoS attack. Hello Zoro Live, welcome to the channel. And about DDoS attack, we will be studying about that in the upcoming lectures. And we have already covered DDoS like attacks in our previous series of ethical hacking, but it was covered in Hindi, so we are now doing this series in English. So you can check that out as well. I hope I provided the link in the description. Let me check it. I don't think I have. Yeah, I will put the link in the description. So here, network layer routing occurs on the network layer. Then is next is your data link layer. So at data link layer, here we had the packet, right? We had IP address segment equal to your packet. Now this time we also have, or what do we call it? MAC address. MAC address plus your packet equal to plus trailer. What is trailer? Trailer is end of the packet, and this makes your frame. So here devices like switches work, and on the network layer devices like routers work. And lastly is your physical layer. So on the physical layer, this frame is converted into bits, and the data is transported in the physical medium. What is your physical medium? All that we studied in the networking part was just to understand this OSI model today. OSI and TCP IP model. So physical layer, on physical layer the data is converted into bits. What is bits? Zeros and ones. And the data is transmitted on the physical medium like cables or wirelessly. Okay. So on the application layer, we saw that there was you on the user interface. I sent you the file. I sent you that file, like for example, using the FTP protocol. Then whatever that file was compressed, encrypted, and translated into the sender's format. Sorry, receiver format, or not receiver format. Actually, it's common format. Okay, it is converted into the common format. Now, session on the session layer, the session is established, maintained, and terminated when the data is completed, is sent from one system to another system. Then on the transport layer, the data is converted into small segments. Then on the network layer, the segments get some IP address for the routing. On the data link layer, these packets got MAC address and they are called frame, and then these frames are converted into your zeros and ones. So conversion of data to bits is called your encapsulation. What does it call? Encapsulation. Conver- Conversion of data to bits. This whole thing is called encapsulation. We are encapsulating the data. And guys, if you get any doubts, any questions, let me know. Another term is decapsulation. Now, in through the physical medium, the data reaches the receiver's format, receiver system. Sorry. Okay, so now in with the help of cables, it reaches from one system to the another system. What will happen? This these bits will get converted into the frame. Then the MAC address will fall off, and it will be converted into the packets. Then it will be converted into the segments, and then the data it will become data. The complete data will be shown. The complete file will be shown into the system, and the data will get decompressed. Previously, it was compressed, no? So it will get decompressed, decrypted, and translated into the receiver's format. Trailer is just end of the packet. Sandeep, welcome to the channel. Trailer just means end of the packet. So then from the receiver format, it will and then it will be shown on the user interface. I will be able to, or you will be able to open that file. Whosoever the receiver is will be able to see the file into their user interface. Okay, let's see that again. Here we saw on the application layer, interaction between the user and the application takes place. On the presentation layer, data is translated, encrypted, and compressed. Then on the session layer, the session is created, terminates, and managed. Then on the transport layer, manages the delivery and the error checking of packets as well. And protocols like UDP and TCP are used. Okay, so manages the delivery and error checking. Next is your network layer. On the network layer, routing occurs and IP address is added. So it decides the shortest path or the best path among the routes to transmit the data. Next is your data link layer. Data packets are converted. These here on the network layer, it becomes packets. So packets are then converted into the frames and are shared between the nodes. And on the physical layer, physical medium where data is transmitted into zeros and ones or your bits. Okay, so let's see the encapsulation and decapsulation as well. Encapsulation and decapsulation. Just give me a second. I'm looking for an image for better reference. Guys, if you get any doubt, let me know in the comments. Also, do not forget to like the video and subscribe to the channel and keep learning with White Fortress Cybersecurity. Where is it? Module 2, Module 10. Oh, 9. We do not need Kali lyrics today, but surely we will need it tomorrow. Where is my OSM model? What? Just give me a second. Disappeared or what? Yeah, here it is. Okay. So here you can see encapsulation. So from the source, the data leaves in the data format only. On application, presentation, and session layer, the data will remain data. Then on the transport layer, there is a segment header because the data is converted into small segments. So this is your segment header. Either TCP or UDP will be used. Depends on which protocol is to be used further. If it's gonna be HTTP or HTTPS like protocols, what will happen? TCP will be used. If the packets are for the video calling or stuff like that, so UDP will be the segment header. So then data segment header and there is packet header. Now on the network layer, the data is converted into the packet and this is gonna be your packet header, IP address. Then on the data link layer, this is data, this is a segment header, this is a packet header and your frame header will add. Here on the data link layer, this data becomes frame. So frame header will be your MAC address. Then at the end, there will be a frame trailer that is end of your packet. Then this complete frame will be converted into bit sequence. It will be converted into the signals. Okay. Then what will happen with the signals from one system to another? The data will reach to the receiver system. What will happen? Then this bit sequence will again turn into the frame. Then this the frame header and the frame trailer will fall off. Then the packet header will fall off. Then the segment header will fall off and the data will be decompressed, decrypted, and translated into the receiver's format, and it will reach the destination system where it will be displayed to the destination system. In the everything will be there. Okay, so encapsulation adds header and the trailer information to the packets as it travels from the source to destination. As the packet continues towards the receiving device, decapsulation removes the header and the trailer, leaving the original data. So, this is how your data is transferred from one system to another system. I hope this is very clear to you guys. And these are the protocols. I told you these layers are nothing but some set of protocols. And guys, there are very little likes. Do not forget to like the video. And if you get any questions, do let me know. Now, and we are almost reaching 2000 subscribers. Thank you so much guys for your support, and let's continue. Okay, so here we have got OSM model, all the layers, and on the application layer, what are the protocols? HTTP, FTP, DNS, SNMP, and telnet like protocols are used. On the presentation layer, SSL, TLS layer, these are the protocols used for the encryption part. And session layer, on the session layer, NetBIOS, PPTP like protocols are used. On the transport layer, TCP, UDP protocols are used. And on the network layer, IP, ARP, ICMP, IPsec. I told you, no, that IP addressing is done over here. ARP, ICMP like protocols are on the network layer. Then on the data link layer, Triple P, ATM, Ethernet like protocols are used, and on the physical layer, your Ethernet, your cable, your USB, your Bluetooth is your wireless media. These are all used. Now, the last topic for today, TCP IP model. So, all these three layers of OSM model, application, presentation, and session layer comprises and makes your application layer. Okay, so all these layers, like I told you, whatsoever happens in the application, presentation, and session layer, all that all that comprises the application layer of TCP IP layer, TCP IP model. So the protocols that are used in the application layer are same as the protocols used in application, presentation, and session layer of OSI model. So HTTP, FTP, Telnet, NTP, DHCP, DNS, these are all protocols in the application layer. Next, OSM model's transport layer will remain transport layer in the TCP IP model. Network layer will become internet layer in TCP IP model. IP, ICMP, ARP like protocols are used. OSI model, so its data link and physical layer becomes the network layer in the TCP IP model. So TCP IP model is is the physical model which is actually implemented while in real life. So, and OSM model is a logical model. It explains all the working and everything. And guys, please do not forget to like the video and subscribe to the channel. We are almost hitting 2000 subscribers. Thank you so much for so much love and support. So, and in the description, you can see the phone number where you can also contact us for your doubts. And if you need certification, any certification related to cybersecurity and want to pursue career in cybersecurity, you can contact us on the number. Also, you can see the registration form in the description. You can contact us on that. You can register for that and we will get back to you. And with this, let's end today's lecture. And tomorrow we will be doing HTTP in detail. Okay. So tomorrow is a very basic yet very important topic. And if you do not know the basics in cybersecurity field, it's useless to go for the further topics, right? So we will be covering HTTP in detail tomorrow, and the classes will be 5 to 6 only, 5 p.m. to 6 p.m. in the Indian Standard Time. See you tomorrow, and thank you so much for watching. Thank you for the likes and subscribes. I hope we hit 2000 subscribers by today. Okay, bye bye. See ya, guys.